Hey, on Wednesday, the 7th, no, excuse me, the 8th of February, today, we are looking at cross sections that are not circular in shape. Okay. So up here we had discs and then we had washers. So discs was on Monday, washers we did yesterday on Tuesday. And today we're going to do shapes that are non circle cross sections. All right. It's going to be a little tricky. I'm going to go over example 4. So in your notes, I would like you to put down example 4, and it's on page 245. 245. And what they're saying is that they're going to take a piece of wood that is 2 by 2 by 4, and they're going to cut it down, they're going to shave it down, and it's going to have a shape that's defined by this function, y equals the square root of 4 minus x. So the square root function has undergone some transformations. The negative is going to make the function go and reflect over the y-axis. So the normal square root function, the parent function, goes this way, right? But now it's going that way. And then the 4 is going to shift it 4 over to the right. So we're going to have a square root function that looks like this right here. And I'm going to show you a picture of that in a moment on Rhino. So, this general shape is defining the top view of our object, okay? So here's the top view of our object. The square root of 4 minus x is this function right here. Now, if you're looking at page 245 in the textbook, what the author is doing is they're shifting it over like this. I'm going to try to get it so it's sitting kind of like what the author is showing us. They're kind of showing us one of the sides over here, and they're trying to give it a little bit of perspective. They've also turned on, I would say, like somewhat of a see-through method so that you can see this face back here. Now, this back face is just a square. Okay, that back face is a square. And so every cross section perpendicular to the x-axis, every cross section perpendicular to the x-axis is going to be a square. So when we think about how are we going to set up our integrand, well, let's do a little bit of work right now. Because it's non-circular, it's not going to have a pi in it. There's not going to be, try that again, there's not going to be a pi symbol in our problem because, well, unless it's part of the function, because we're not dealing with a circle. We had pi up here involved because we had pi r squared. That's the area formula for a circle. But now, because each cross section is a square, and they tell us that, in the problem, we're going to have one side of the square squared. So this is going to be a side of our square, and then we're going to square that, and that's going to be the area of the cross section. Now, the thickness of the cross section is going to be dx, because I was saying that in the problem they say every perpendicular cross section to the x-axis forms a square. All right. So with all that out of the way, I'm going to change my drawing here. I'm going to turn some things off, like the base edges, or excuse me, the edges are in black. Let me turn off the red base, which that didn't do a whole lot, but the cross-sectional, I'm turning on a cross-section in there. I'll show you that in just a second. I'm going to turn off the lateral faces. So these are the functions that defined the surfaces on the sides of our solid. The square root of 4 minus x is here. It's also down in that plane. It's coming up out three-dimensionally out of the xy plane into a z direction, into a third direction there. So I hope I'm making that clear how our object is defined. Now, what I'd like to do is turn on some cross sections. And there are a lot of them here that I have drawn in. And I'm going to turn off most of them. And we're only going to see one particular cross section. You kind of see it there in purple. We're going to just view that one without all of the distraction of all the surfaces and all that stuff. Okay, so here we go. I'm going to turn off most of the cross sections, and I'm going to turn off the edges for a second. Okay, so here is our square. We need the area of that one square, and then we could put it, right here as the integrand. Now, where are the squares going to go from, where are they going to start and where are they going to stop? Well, the first square is over here. And this, by the way, remember that the red is the x-axis right there. They're telling us that's the x-axis. So this is 0, and then it comes all the way out here to 4. So let's look back at our notes for a second. This would be kind of important to make a note of. This is 4, and this is 0 over here. And one cross section is going to go like right, I'm just going to draw a random one like you saw in Rhino a second ago. And so here's my one square, right? So let's do that. Let's turn those back off. Most of them are turned off and the edges are turned off. And how would we find the area of this thing? Well, let's look one more time at the edges. If we're looking from the top view, let's see here if I can get this lined up right. And I'm going to move this over a little bit. So we're looking straight down on that square, like right there. We're going from the x-axis straight up to the function 4 minus x. So that's what that distance would be, the square root of 4 minus x. So let's label our square, like I would take that square maybe and just, lay it flat down on my paper. And the distance from, here up to here is that square root of 4 minus x. So that's what one of the sides is, square root of 4 minus x, and the other side is square root of 4 minus x. And so we're going to replace this right here with the square root of 4 minus x, and we're squaring that, which is super nice. It's going to undo the square root sign, right? And we also need to put some limits of integration on this thing. So as we were saying back here, the first cross section happens over here at 0, right there at 0, and the last cross section happens over here at 4. So we're going to go from 0 to 4, okay? And to finish the problem off, you're going to, simplify a little bit. So we get 4 minus x dx, right? So that's squaring the square root, as I mentioned before. And then we could take the antiderivative of each one of those guys. So I get 4x minus x squared over 2 from 0 to 4. Now I could plug in the 4 and I get 16 minus 16 over 2. Okay, and then I plug in the 0 and I get just 0. And so I ended up with 16 minus 8, which is 8. So the volume is 8. Now, will Rhino do that over here for us? It might object a little bit because our surface may not be completely contained, and it might have some gaps, like these surfaces, these lofted surfaces, there might be a little gap, and so it might freak out. But I'm going to try it anyway. So we're hoping to get 8 on Rhino. It says select your object. So here we go. I'm going to select my object. I'm going to hit enter. It says it may not be everything enclosed. It might not make complete sense, but you know what? We're expecting it to be close to 8. If it's way off from 8, then either we made a massive mistake or Rhino is totally messed up because it has too many openings. Okay, so I'm going to hit yes. I want to continue. I want to see what it says. So 7.932, 7.932 is whatever, 68 thousandths off of what it's supposed to be, but it's pretty close, like it was pretty close to 8. And again, it's because of the way Rhino is lofting it, that's a little bit less than 8. I hope I'm making that clear. Today, our goal is to be able to visualize that cross section, come up with a couple sides. If it's a rectangle, these two are going to be different. If it's a triangle, we're going to use 1/2 base times height. So you just have to figure out what that cross section is. Now, maybe a better drawing than what I made would be useful. And in that case, I would recommend you lay your paper on the book and try to trace out what they're doing. Okay, because it is a challenge to draw some of these things. Like, they've got the square root of 4 minus x here, and then they're trying to draw it in perspective like this, and then they draw their object kind of like this, and they've got the square root of 4 minus x coming this way, and then you'd have this back corner, which you can't very well see, this back corner back here. So that maybe is okay. And then one of our little cross sections is like in here. And like I said, drawing this can be a big challenge. Now, the way I've drawn it makes it look like a rectangle, not a perfect square, just kind of like a more tall than it is wide. But you have to go based on what they say, that each cross section perpendicular to the x-axis forms a square. And I hope I'm making that clear. I know you can do this. They call this like a slab. This little picture right here is the slab. And what is the shape of the slab? Um, Again, I know you can do this. All right. Thanks for watching the video.